Now we begin the recording of this. Well, this is the point. The formula you were using to solve these problems was derivative respect x of e to the x is e to the x. Possibly this is the formula, the easiest formula to remember. The derivative of the natural exponential is the same function again. If you remember, the derivative of the sine is the cosine, and the derivative of the cosine is the negative sign. So the trigonometric function bounces from one to the other one, just changing signs. But the exponential, this one especially, the derivative of the exponential is exactly the same. So it doesn't change. And that's a nice property. What happens when you have, for instance, the derivative respect x of a composition, e of x squared? As well, this is going to be very simple because it's the function of a function. You put e to the x squared, and then you multiply times the derivative of the exponent. So this is the general formula. You have e to the u is e to the u again times u prime, assuming u is a function of x, correct? So this is the formula you were using in the first part of the assignment. In the second part of the assignment, we took the integral. So we have the derivative of e to the x equals e to the x. If we take the integral both sides, like this, the derivative cancels the integral, so we find also that the integral of e to the x dx is e to the x plus a constant. So it's also an interesting property, correct? So not a big deal to remember these two formulas. These are easy to remember. The derivative of the natural exponential is the same function. The integral is the same function plus a constant. So possibly is the easiest formula to remember. Alejandro Cardona, okay. Right? So now what I'm going to do is switch to the natural log. Okay, so for the natural log, let me just erase this part here. So the function f of x equals the natural log of x. As you know, ln is the inverse of e to the x. So the exponential and these are inverses. What does mean this? It's very simple. That if you make the composition, as we learn in pre-calculus, this is going to give me a single x, correct? So the functions are inverses, so we have this property, correct? Now, my situation is, okay, this is a function, a normal function. We can know the graph. The graph is something like this. What is the derivative respect x of the natural log of x? This is, well, this is what we are going to discover now. To do this, we're going to use the chain rule and the fact that e to the ln x equals x. So we know this is true. The exponential of the natural log is x. And also we're going to use this derivative respect u, right, of e to the u is e to the u times du dx. So this is something we're going to use. We're going to add these two formulas and we're going to get what we need. So what I'm going to do is very simple. I'm going to take the derivative both sides of e to the ln x equals d dx of x, correct? Now, this derivative, everybody knows this is a 1, and this is going to be split using this. So this is going to be e to the ln x times derivative respect x of ln x equals to 1. Now, what I'm going to do is a little bit algebra. This is x, so I'm going to change x times d dx of natural log of x equals 1. And finally, I'm going to find that d dx of ln x is solving for the ln x here 1 over x. So this is going to be another formula we are going to use a lot. So try to remember this formula also. Derivative respect x of the natural log of x is the reciprocal function. And also we're going to find that if we integrate this expression, so if we integrate the dx of ln x, integral 1 over x dx, the derivative and the integral are going to cancel, so the integral of 1 over dx is ln x plus c. This formula is going to also very useful. Why? Because if you remember in our previous classes, we have this integral of u to the n du was u to the n plus 1 over n plus 1, the famous power rule. The only situation we have is that n cannot be -1, correct? Now, this is -1, x to the -1, so this formula is going to fill the gap this formula has, okay? So, this is the new formulas we're going to be using now, correct? But before that, I want to review logs, okay? Because it seems that logs are not very nice for you. So let me just change screen. Let me just check this one. Yeah. This is the assignment you can see in the Google Classroom. And you can see these problems, correct? So we are going to expand this expression using the logs, in this case, the natural log only. Now, what properties we are going to use? Remember these properties? Properties of the logs. The log in any base of the power is the power times the log of the base. The log of a quotient is the difference of the corresponding logs. And the log of a product is the addition of the logs of the factors. Please, important, you must remember these rules for this chapter and from now to the end of the course. Okay? So, let me just erase right here. And let me just go back to the problem we display over there, problem A, right here. Problem A is ln of 10 times x times a square root of x minus 3. Okay? Now, this is the lateral log of the product of three things. Okay, I'm going to remember, I know it's not this one. This is for pre-calculus. These are the rules, so I'm going to use this one. Whatever you do for 2, you do for 3. So this is going to be the addition of the log of this, the log of this, and the log of this. So this is going to be ln of 10 plus ln of x plus ln of the square root of x minus 3. Okay. Have you done? No, because you have a square root. And if you remember that the square root of a number is the number to the 1/2, this is a power. So you are going to use the log of the power. So you're going to put the 1/2 at the front of the expression. So this is going to be ln of 10 plus ln x plus 1/2 ln of x minus 3. This is my expansion of this expression, correct? Now, this is the point. With the logs, you can split a complex problem into 3 simpler problems. This is going to be very useful. You are going to see how. Okay? Any question? I guess it's very clear. This is review from pre-calculus. Okay, another problem. A little bit more complex. Suppose we have now B is ln of the square root of x squared plus 1 over x cubed plus 5. Okay? Now, remember the same. The square root is a power. So this is the same as the natural log of x squared plus 1 over x cubed plus 5 to the 1/2. Okay? Now again, remember your logs. I have to use the power rule. Okay? So this is going to be 1/2 ln x squared plus 1 over x cubed plus 5. So this is going to be using the corresponding quotient rule, is going to be 1/2 ln x squared plus 1 minus 1/2 ln x cubed plus 5. And this is my answer. Pretty much you remember those times in pre-calculus. It's pretty much the same. Okay. Another example. Let me just, try, let me see which one. This is if I want. Let me just grab another one. Right here. Oh, this is the 2, not this one. This one. Okay, no. Well, this one is fine. Let me just open this one. Open. Okay, this one. Actually, yeah, this is fine. Okay, this is the homework. This is what we have been working. Okay, one of the next ones, possibly the most scary one with the tricks. Okay, we have C ln of x squared sine cube of x over a square root of x squared plus 1. Okay. Okay, there it is. Here is my expression, my terrible expression. Well, not a big deal. So remember that you have a product of 2 powers at the top divided by the power of this expression. So you can split this as the product and the quotient. So you put this one, ln x squared plus ln sine cube of x minus ln, remember this is a power, so x squared plus 1 to the 1/2. Then I have to move the powers out of the expression, so this is going to be 2 ln x plus 3 ln sine x minus 1/2 ln x squared plus 1. This is the expansion. So it's not that difficult if you remember these rules. The secret is right here. If you remember these 3 rules, everything is going to be smooth and easy. Okay? Another example, but now in reverse order. So if you see the screen right here, this one, yep, you're going to see that now you have the expanded expressions. So we're going to compress them. So let's do the first one. 4 ln 2 minus ln 3 plus ln 16. Okay. So this is the expression I want to solve. Okay. Now I'm going to remember the rules. My rule tells me that if you have a number at the front, you can put it as an exponent. So I can write this one as ln of 2 to the 4th minus ln 3 plus ln 6. Now I have to remember my elementary school math. I know that I can add these two first. So I can put ln of 2 to the 4 times 6 minus ln 3. What I did, I add these two first. That's the product of the numbers according with the log, minus this one. Okay, now this is going to be the quotient of these two expressions. So this is going to be ln 2 to the 4 times 6 over 3. Obviously, we can perform these numbers and then we can find a final answer that, well, at this moment is not really important. So the only idea is to show you that we can use the same properties to compress the expression in case we need that, okay? Let me just move now to another example. So again, you have this one. Let me just select one extra only. You are my best kids, so I'm sure that you remember this. So suppose I have the g is 2 ln x plus 1 plus 1/3 ln x minus ln cosine x. Okay? So that's my expression. So I want to compress this thing. Okay. Numbers at the front of the ln I powers. So here I have none. I have here 1/3 and I have here a 2. So this is ln x plus 1 squared plus ln x to the 1/3 minus ln of cosine x. So this is a 1, so that's not a problem. Now I have the addition of these two logs, same base. So this is the log of the product of these two expressions. So it's ln x plus 1 squared times this 1/3 is the cubic root. So I'm going to put the cubic root. And then I have an extra term I have to compress. This difference is the quotient, the log of the quotient of these expressions. Remember. So this is ln, big line, cosine x at the bottom, and at the top, x plus 1 squared, the cubic root of x. That's my compressed expression. So I guess everybody recall that logs work in this way. So the idea is we use these properties in calculus to make our lives simpler. How? Well, I'm going to show you. Same assignment. Now I have to get the derivatives of this expression. Let me just begin with these difficult ones. This is, oh my God. Well, let's see. Let's take this first one. So y equals ln of x square root of x squared minus 1, correct? Let me just go back to my board. Okay, here is the expression on my board. Now, what rule I have to use? Well, I have to remember that derivative respect x of ln of u has to be 1 over u times u prime. Well, this is easy to calculate then. So y prime has to be 1 over x square root of x squared minus 1 times the derivative respect x of x squared minus 1. Okay. The first step was easy. Just take the reciprocal of this thing. But the second one is going to be horrible. It's going to be horrible. This product with a square root, that is going to be bad. It's possible to do it, but it's going to take us a while. So what is the option we have? Okay, the option is this. Remember, same as in real life. You have a big problem. It's a good idea to split a big problem into little problems. So I'm going to use the properties of the logs. So I'm going to break my expression as, I'm going to write the expression right here again. Y equals ln x square root of x squared minus 1. So I have the product of these two elements, and this is a power. So I can, in a first approach, do this. Ln x plus 1/2 ln x squared minus 1. Now, the only thing I have to do is take the derivative of this expression. So I got the derivative of this and the derivative of this. And these are going to be easy. Check. Y prime is the derivative of this. Well, I have to remember the formula. The formula says take the reciprocal of the expression times the derivative of the expression. So this is going to be 1 over x times the derivative of the x1. Very simple. Plus 1/2, the constant is out of the derivative. Now I have to take the derivative of this, so I use the formula. The reciprocal of the expression, 1 over x squared minus 1, times the derivative of the x squared minus 1. Oh, that's easy. It's 2x. Okay, so writing this, 1 over x times 1 is 1 over x, plus these two cancels out, and this expression is going to be x over x squared minus 1. That's my answer. Now, check how simple was this process, right? Compared with this derivative. Here is a simple part. I have just to write this reciprocal. But now I have to do this derivative. That's terrible. But if we use the logs first, you see, I have two easy expressions. I get the derivatives. And if you add this one and you do this one, you're going to get exactly the same answer, even if you don't believe it. So the product of this times this derivative is going to be this one. Believe me, is true. But this is easy. Okay. Questions at this point? Remember what I'm using? These properties. Okay. Another example. Let me just now go back again to my assignment. So I have this one. Now let's try F. This one. F. Okay, so that's no, that's D. Sorry, D. So I have ln parentheses x over x squared plus 1. Okay. Okay, I have it in my board. So let me just go here. So this is my expression, so I need y prime. Okay, y prime is the derivative respect x of x over x squared plus 1. And this is going to be okay. Well, ln, right? And well, I know the formula. The reciprocal of x over x squared plus 1 times the derivative of x over x squared plus 1. And again, this is bad, correct? But now let me just use the properties of the logs. So this expression now is going to be y equals ln x plus ln x squared plus 1. There is. Okay, now I'm going to take the derivative. Y prime equals. Derivative of this, easy. 1 over x. Derivative of this, reciprocal. 1 over x squared plus 1 times the derivative of this, 2x. Rewriting 1 over x plus 2x over x squared plus 1. Answer. Everybody? So the logs are here to make our lives simple, not miserable. Okay? More examples. So we go back to the screen, right? So we have, for instance, E or F. Any of them is going to work. Let me just E, y equals ln x. So stop share. Okay, well, I need y prime. Y prime. Okay, in this case, this problem is a trap because in this case, you have to take 1 over ln x. So derivative of this is the reciprocal of this expression times the derivative of ln x. But this is not that bad because this is 1 over x. So this is 1 over ln x times 1 over x. That's my answer. So This was not a problem really. This was fine, but not the next one. Check. Right here. Oh my gosh. Yep. So you have problem F equals f of x is the ln of the square root of 4 plus x squared over x. There is. Okay, back to our board. Here is the expression I have to get the derivative. Well, I'm not going to waste my time trying to do this directly, so I'm going to split this with the logs. So I'm expecting you are able to do this in one step now. So this is 4 plus x squared to the 1/2, and this is a quotient. So this is 1/2 ln 4 plus x squared minus ln x. Okay. So here is my expression. Now, f prime of x is going to be the derivative of this. Okay, I know the formula. I'm going to write it here. ln u, 1 over u times u prime. So this is the formula I have to use. So I'm going to have 1/2 times reciprocal, 4 plus x squared, derivative of 4 plus x squared, 2x. Minus this, well, is the same thing, so it's 1 over x times 1. Okay, simplifying a little bit, I have these two cancels out, x over 4 plus x squared minus 1 over x. Now, you don't have to compress this thing. This is correct. Okay, so not a big deal. Last problem. Yeah, this one, G. So this is G ln x squared minus 1 over x squared plus 1. Okay, I stop the recording. And now this is going to be my problem. Of course, this quotient and this product is horrible, but if we split it in portions, this is going to be the ln of x squared. So it's 2 ln x times this one, so plus this ln. So, and this is a power 1/2. So this is plus 1/2 ln x squared minus 1 minus this one because it's dividing, minus this log, minus ln x squared plus 1. Okay. This is really algebra. Now I'm going to do the calculus. So if this is y equals, right? So y prime is, and this is the only calculus we're going to use. Okay, so it's twice derivative of this, 1 over x, plus 1/2, times derivative of this expression, the reciprocal, 1 over x squared minus 1, times the derivative of this expression, 2x, minus derivative of this expression, the reciprocal of this, 1 over x squared minus 1, times the derivative of this x squared plus 1, 2x. Okay, now I can write this again. Yep. And this is 2 over x plus these two cancels. So I have x over x squared minus 1. And this, well, this is just 2x over x squared minus 1. That's my answer. So the logarithmic differentiation is going to be something very, very, very useful when we deal with difficult problems, correct? Yep. Any question at this point? No complaints? Are you still awake? So not a big deal. Now, for you, this one is the homework. Let me just share the screen. So share screen. This is the homework you can also download in my Google Classroom. So you go over there, you can download this assignment. So you are going to have practice here of the application of the logs. So you can do these derivatives, right, using the logs. Now, here is a trap. This is very important. If you remember your properties, let me just go back to my board. The properties of the logs involves multiplications, right, and divisions and powers, never ever addition or subtraction. So if you have something like log in any base of u plus v, this is not log in base a of u plus log in base a of v. This is not possible, okay? So this is a mistake. Don't fall in the trap that you see here. A plus is the plus of the logs. Never ever. So the rules are these ones here above. And they are related with powers, products, and divisions. Never additions or subtraction, correct? Never. Okay, so in this case, in the case of our homework here, so this is not ln of x plus ln of this. You have to do 1 over this times the derivative of this, okay? Be careful with that. Now, these ones, yeah, implicit differentiation. Okay, let me just review something about implicit differentiation because I'm sure you are not recalling this very, very well. So let me just suppose I have a function like this. X squared y plus x y squared equals, I don't know, 3 equals 3. Suppose you have that one. This expression is not in explicit form. So to make it a function, we have to solve for y equals. So possibly it's not going to be that difficult, but possibly it's going to be. So I'm not going to try. Let me just remove a y to make this more difficult. Okay, so okay, possibly we cannot solve, but I'm going to put it back better. So how can we solve this without solve for y? Well, the first one, we're going to assume y is a function of x. Then this expression is x squared times a function plus x times a function squared equals something. So remember to take the derivative both sides. V dx of x squared y plus xy squared equals 0. Then you can do what you know. This is a product, so you use the product rule. Derivative of this, 2x times y plus x squared derivative of y, dy dx, plus the product of this, derivative of this, 1 times y, y squared, correct? Plus x times derivative of this, so derivative of the power, 2y, times the derivative of what is inside of the power, dy dx equals 0. And remember, what was the most difficult part? This one. Once you finish your calculus, you have to solve for this thing. And don't be scared. This is a linear equation in this variable dy dx. Xy, x squared, y squared, and these ones are numbers that we are going to treat like that. So first we're going to take these two numbers, remember, and then you're going to move them to the right side. So we have x squared dy dx plus x 2xy dy dx equals negative 2xy minus y squared. So I move this to the right. Then this number and this number are not a problem because they are not the numbers I have to solve to. These and these are my variables. So I'm going to factor x squared to xy, yeah, dy dx equals negative 2xy minus y squared. And what is the last step? Well, this is a number times my variable. So according with algebra 1, dy dx is negative 2xy minus y squared over x squared plus 2xy. And that's my solution. I hope you remember the implicit differentiation, because here you are going to use the implicit differentiation with the logs. Okay? So I'm going to repeat these problems, not the same problems, a problem like this one next class. So I'm expecting, in case you have any problem, well, you can ask something, or right, you can pretty much review this again. Okay, so any question? It's very important for me, your questions. Please say something. No, I don't want you sleeping. These are going to be short classes. Yeah, but I cannot do too much, so I have to give you pretty much how to solve the questions and all those things. No questions?
When's the next class?
Technically, it's tomorrow at 10, but I'm possibly going to shift the class to 11. Why? Because there is a math department meeting at 10. So I want to attend that one. So after the meeting, I'm going to do this class, correct? So it's going to be like this one, 30, 40 minutes. Okay?
Okay.
No problem. So Ibanez, you quit?
Do we have any class on Wednesday?
On Thursday? Technically, I want to do this every day, correct?
Okay.
So if you cannot attend the class, remember I'm going to save this video in the YouTube channel, in my YouTube channel, so you can go over there and check what happened in the class. So you are not missing everything. So this is live. Well, it's fine. You can ask questions directly, but you can see this video, right, in YouTube, and then you check the problems, and then you can take this class as any time you want. Okay, seniors?
What's your YouTube channel?
I'm going to put the link in the Google Classroom, okay? Once I upload this one. Yes, let me show you. So, what is the Google Classroom? Right here. Here, okay. Here. Screen. Okay, you see? I have here APCalculus AB in the Google Classroom. I'm assuming you are enrolled. You're enrolled, most of you. Here is the people enrolled. Yeah, you can see your names, right? So here in the stream, I put the content of the class, of the session, here the assignments, and possibly here I'm going to put the link to the YouTube channel, correct? So just be aware that I'm going to be posting here. Here is the code for the channel, you can see.
From this last time that we went?
First time.
So this is the class code, so you can enroll using this code, obviously.
Yeah, because you went to grandma.
And here is everything. Okay. So every day you're going to put posting something. Okay.
Okay.
And in case I'm going to send you a remind, a text message in your cell phones for any situation or problem. So tomorrow I'm going to be at 11. Okay. Everybody.
At 10, or do we just wait for you to say 11 on remind?
No. I'm going to open the session till 11.
Oh, okay.
Okay. So I'm going to stop here the recording.